Hello, hello, hello. Welcome, welcome, welcome. All right. So yesterday we worked already a little bit again on our terrain system. And where do we do it? Terrain system. And then I noticed right when I turned off the stream. It's volume terrain system, right? Nah. That what was the issue again? Because now it kind of works. So I was adding them. Oh yeah, but create mesh, the generate mesh path that I changed from a fixed shader node to a render graph shader node. We actually need to override two functions, which is enabled and is compute task. So the first one is that we actually execute it, and the other one is that it knows that it's a compute task, which is a little bit problematic, not gonna lie, but now it kinda works, but it doesn't really work, and I know exactly why, and that's why the stream title is what it is, because there's two ways to fix that issue, and I can explain it in a second once it boots. But basically, we have it more or less working. Oh yeah, we need to add the material. And then we have it, yeah. But you can see we only see one mesh, and it's actually only rendering one. So first I thought, okay, that because they don't have like a different position, they are all on the same, but it's actually only one. And the reason for that is that we dispatch all of those shaders, and we dispatch for each chunk the shaders, but we bind them, all to the same descriptor set. So basically the last one that we bind wins, and that one is run, and the other dispatches are basically null and void at that point because they're missing their descriptors. Or I mean, they all generate the exact same buffer basically. There's two ways around that. Either we generate, like we duplicate this part, well, actually only in the shader effect. We have the possibility that in the shader effect constructor, basically we add another shader effect constructor where we copy everything from an already existing shader effect and then only generate new descriptor sets. Because then we would have duplicate like new descriptor sets. That would be one way, which I kind of dislike. I mean, we probably need that in the future. Although I think we don't actually need descriptor sets anymore. Once I moved away and added this buffer device address, I think we can get rid of the descriptor set, which would be kind of neat. Because I don't think there's anything we need it for, because we can do everything with push constant at that point, I think. Maybe not, but let's see. So yeah, the plan is, instead of duplicating this 27 times, because we have 27 buffers right now, is changing my rendering backend to support buffer device addresses, which is this thing. And that was already on the list anyways, because it will simplify greatly how I handle buffers in the engine. Vertex buffers and all that kind of things. Well, vertex buffers not that much actually, but the other buffers, like SSBOs, uniform buffers, all of them would be way simpler. So let's do that. So basically, let's do it only for those buffers for now, and then we do the other ones as well. So we go to the terrain, volume terrain system, where we generate our shape buffers. Buffer type. I think we need a new buffer type here. Yeah. So we need one more, which is that even supported? I mean, I guess it is, right? And that is device address. Give me a second, there's someone at the door. Alright, never mind then. My fiance took care of it more or less. Hello Capuchman. Hello. Alright, so we have this device address here. Probably have to handle that somewhere. So basically, if has any flag buff or device address, and we do vk device address bit like that. That should already do that part quite well. Do we need anything else? After that, the memory we bind, blah blah blah. This time it's a pin extract instead. But otherwise requires the VKKRH device group extension. So I think that is kind of obsolete. Now we need this part basically. We're in the create. After the create here basically, I guess. If enums has our flags basically, and properties, bind flags. Is that really bind flag? I mean, probably buffer type. Do I really put that here? Wait, can I even store that here then? Oh, that's barely fitting here in the bind flags. Not sure if that's even worth it what I'm doing here with probably it's not even worth it what I'm doing here with that crap. I don't really like that this is called bind flags, because I think, isn't that what I'm checking here? Yeah. I mean, technically it is the bind flags, but I think I want to change that. Buffer flags. Or do we just call it flags? Fuck it. Maybe even, I think it's more like a usage, right? Usage flags. I think makes the most sense, because that's more or less what it kind of represents. And then let's rename that to buffer usage. Good enough. I think that makes it clearer what it actually is about. And then here, that one we OR together. Buffer usage device address. We probably could do like combinations of those. What is even buffer? Ah, as an SPO, SSPO. Let's actually rename that. Does anyone know what SSPO stands for? Structured something. Shade a storage buffer object, never mind. Maybe we do storage buffer then? Or like just storage? Yeah, let's do storage. Alright, we cleaned that up a little bit. Hello, what's up? Question. I saw you created the ticket. Did you try the stuff that they suggested there to move the project call up? And did that fix that? Because I cannot reproduce it anyways, but I mean, I will do that. I don't mind moving that up. It's just that I would want to know if that actually fixes the issue that you had. Okay, cool. So I guess you, well, let me open it. If I understand it correctly, we just, or I have to... No, I don't have a CMake. Is that in Visual Studio, that in VS Code that I can have a debugger there? Is there an extension for that? Is it an extra one, or does it do it just do the normal like CMake extension here? Or does a normal CMake have a debug? I don't think so. Okay. Oh, maybe we can read, right? You need to specify an indirect flag in Vulkan. What do you mean with that? I mean, this one is what I use, yeah, for indirect, and then in my buffer thing, I do a device address bit, which is the thing for, oh, you mean, the indirect one. Yeah. If you want to use it as an indirect draw argument buffer, you need to mark it as well. If you want to use your SSPO or your storage buffer as an indirect draw buffer. Otherwise, you get a validation. I think it still works, but you will get a validation error. Which is not something you would want, because technically it could fail on some devices, right? The validations are there for a reason. At least so I was told. What they are. So actually, We didn't fully change that, so I wanted to do here, yeah, exactly. So usage flags, usage. Oh, it actually is already, man. Why did I do that then? Why did I call it that stupid name? It's texture usage. We already have texture usage. Why did I call it buffer type? I have no idea, man. Things I will never understand about my past self. So we have that, and if we have that flag, we do this beautiful thing from the Vulkan documentation. Although maybe I don't need to do that. Maybe I get it back already from here. Maybe I get it from VMA. Bind. Maybe I get it back already here. Yeah, I'm not sure. I mean, Vulkan is always a little bit more, let's say, strict, because as I said, it works, right? It's just that you get a validation error if you don't have it marked as an indirect draw buffer. So technically it works. It's just that, yeah, as I said, you will get a validation error. Vulkan memory allocator buffer device address. Device extension, blah blah blah. If you want, call that, which we for now disregard, because I think we will support it, but probably we should check it. Actually that's only for less than 1.2, and we require, okay, it has been promoted to Vulkan core. Then we don't need to do any of that crap. While creating the right device, I don't think we need to do that anymore now that it's core. Well, maybe we do. In the VMA, we need to add this bit. Okay. Allocator info flags. Like that. Okay, the library automatically adds VK memory allocate device address bit to allocated memory blocks whenever it might be needed. Okay, so I guess I cannot get the device address. I mean, we probably could check it. By setting a breakpoint here and then going into the function and see if we get it or if we need to retrieve it. Because the VMA allocation doesn't really help us, right? Because that doesn't have any information for me to get. And that one doesn't really have. Or like device address. Ah. But how does that work? Do we use that here? No. I guess we just call it on the thing, I guess then. Never mind. I guess we just do whatever Vulkan already told us. So we do this. Or VK buffer device address. Oh, what? Did I not just see that? Oh god, where was that? VK buffer device address. Exactly. Oh, where was that beautiful comment block that I'm looking for? Quick demo for the bug. Well, that sucks. I mean, I think it's like kind of legacy that the project is down there. There was not really any particular reason that I did it down there. Okay. Yeah, cool. Okay. I will push that to death. Thanks a lot. Not sure why that was not a thing anywhere for me, but whatever. The wonders of C++ and all the different compilers and tools and whatnot. Always nice that it randomly works on some machines and randomly doesn't work on others. M device. Is that correct? No. Get handle. Actually, let me do it now. Otherwise, I don't forget because I have the thing anyways. Dependencies, source. mean, I guess... I mean, I could do it all the way up there. Yeah, why not? Oh, although... Oh no, yeah, major version, blah blah blah, yeah, we have all of that. Okay. So I think that should work. That should be fine. We will see when we generate the next me. It's bizarre that this never failed on like the... By now I think I tried it on 3 machines. I tried it on my notebook, I tried it on my PC of course. On my PC multiple times with like new setups. What can you do with the device address? So the thing is, what that allows me to do is if you go to that. So do you know what bindless texture rendering is? That would make this a lot simpler to explain. If you don't know it, then I can explain that as well. Okay, so basically it's the same that you do with textures, just with buffers. With the difference though to the bindless one. For the bindless ones you still need like one descriptor set. That's basically an array where you bind your bindless textures, right? For the buffer device address, you don't actually, as far as I understood, we will find out today, but in this documentation it says so. You don't need any descriptors anymore for your buffers. For your storage buffers, uniform buffers, and in theory as well the vertex buffer, if you would want that. So you basically just give it the flag, and then you can get the GPU pointer address for your buffer. This is basically the pointer on the graphics card memory. And then you can do this weird thing here where you in the shader say it's a buffer reference and you need to give it the alignment that has to match. You're basically throwing out all guarantees that the graphics card gives you. You're basically in C++ land with pointer stuff, pointer magic. And then you can just give it the address to your buffer as a push constant, for example. And you don't need to call a bind on a descriptor set. So it basically gets rid of all the descriptor set stuff for you, which has a couple of advantages. Particularly in my case now, is that I have... Exactly, it's bindless buffers without descriptors. Exactly, yes. And the benefit is you don't need to bind stuff, so you can... Because in my example now that I have, so for the volume terrain system, it's not how it will end up anyways, but it will still help in the long run. I have 27 buffers, because I have for each, so I have a 3x3x3 grid of chunks of terrain. Each of the chunks has its own volumetric data, its mesh and its draw command buffer. So we have all those 3x3x3, so like 27 of those in total. And then I wanted to launch a compute shader to fill them with like some initial data. And currently that's a bit of a bug in my engine anyways, but the device address will get around that, is that I create the shader and the pipeline, and then each shader and pipeline is matched together in what I call a shader effect. And the shader effect is basically just combining the shader modules and the pipeline plus the descriptor sets. So here you can see that we have the descriptor sets. The problem with that is, now that I had like 27 dispatches here, the last buffer that was dispatched overrode the descriptor sets for all the previous ones. So the only way around that would be either I duplicate this 27 times so that I have 27 different descriptor sets where I can bind each individual triplet of buffers, or I delay it always by 1 frame. So I do like in 27 frames I do my initialization of the buffers. That would be the other way, so that we do 1 per frame, for example. That would be another way. Probably the best one would be in like in reality, either like merging the buffer somehow. That would be another option, which will probably be the thing we do in the end anyways. But the device address helps with other things as well anyways, because you get rid of the descriptor sets, so you get rid of the rebinding of uniform buffers and stuff like that. The descriptor buffer is not supported in a render doc. Well, that would be a problem, but we will find out. Is it not supported by now already? That would be unfortunate, because I still would want to be able to debug in render doc. If you tell me that now, that's a bit of a problem, but well, I guess we will find out if it works or not. And then what buffer device address info? What do I give it here? Oh, it's a struct, right? That I just kinda didn't do here. So I do this basically. So we go to my buffer. That's the wrong one. Ah, the descriptor buffer extension, which makes... Ah, okay. I see. Ah, I think I read that one, yeah. I read that somewhere as well. True. But I didn't look into that too much. I think, yeah, I remember reading some stuff about that as well. Where did I want it? I wanted to put here, or do we do it in the buffer actually? We could put it here, although that's not exactly the same thing, right? How do we do it with the texture actually? Ah, that's in the handle, right? Although, no, it can't be in the handle completely. It has to be somewhere else as well. Texture, can't type, I guess. Texture storage. It's not here? Is it really just in the texture handle? No, or is it in the texture view? Oh, it's in the texture view. Okay. So I guess we do it on buffer actually, maybe. So we would do here, we get back a U in 64, okay. Maybe we do it like that. And then here we do U64 get GPU pointer, or get GPU address. Let's do that. Return GPU address actually. I mean, yeah, it's a little bit problematic maybe that we... Not sure how we would port that to DirectX, to be honest. If we ever do that. But so far my plans for adding DirectX are minimal. And now we have here, I guess that's the VK buffer, right? Okay, yeah, M buffer. And then GPU address is that? Let's actually... Why did I not do that already? Auto device. I mean, it's anyways inlined kind of the thing, but it's still nicer to read. We have it everywhere like that. Oh, we don't need that. This feature is not like getting the address right. Yeah, because it even says it that it's like a unique thing to Vulkan. Here in the first paragraph. Yeah, I'm not too familiar actually with the low levels of DirectX 12. I mean, I worked on DirectX 12 on Snowdrop, but not in the like lower levels, so I can't really say how it works there. I know we had bindless textures, right? So that's a thing for sure, but I have no idea how the buffers really work in DirectX 12, like on the low level. Because it was all wrapped away as well, mostly. And I didn't really have to go too deep into it. Let's actually... What do you want here? An S32 and you are in a U32. Well, that is kind of unfortunate. What is VK device size? You in 64, okay. Well. So I think we should have everything here. This should now trigger, hopefully. Once it builds. And with that, I think we should already be good to go, hopefully. Unless I really have to enable it somewhere in the device, which is not a big deal anyways as well. But if it's really in core, I don't think I have to do anything. I think it's automatic. Oh, what? Unresolved. Oh, we want this. You would need descriptors to do bindless buffers, but it's not a problem since you create all of them in one descriptor heap. Ah, okay, so the buffers are closer to how you do the bindless textures, right? Then, in that case. Which actually is not such a bad thing anyways. I think it's kind of weird that Vulkan does like two different things, right? It's a bit odd that there's like two ways for that. Oh yeah, okay, we have one. Yeah, it's exact same actually, okay. Yeah, it's kind of weird that Vulkan split it into two different versions, right? That like the textures you have with the descriptor set, but buffers you can suddenly use without descriptor sets. Kinda weird. Alright, so that works, and now if we go to volume terrain system, is it here? Well, kinda. Actually, we go here to generate mesh. We should be able to not do that anymore. According to the documentation, there's none. And actually it can be a little bit better because as far as I read, I mean, it always depends, right? You have to measure. So that's another thing that I will probably have to do eventually. The thing is, you don't need to bind the descriptors anymore. So technically you kind of get around that part, which at least on the CPU side, right, saves you a little bit because you don't need to call the bind anymore for the buffers. But yeah, not sure about. I mean, I would have assumed there's a good reason why Vulkan added descriptors to do some performance stuff or maybe something like that. But realistically, it seems like they move away from it because with like all the stuff they did in later versions, they moved away with a lot of stuff that they did early on. Like you don't need render passes or frame buffers anymore. You can use dynamic rendering and suddenly it works as well. And there's almost like no penalty for that as well. And they actually recommend doing that for most platforms now. So I'm a bit confused about that one as well, not gonna lie. Yeah, let's do a U64 then here. Can I do that actually? I should be fine, right? Buffer or voxel grid address. Then here we do that, and we do a volume chunk, grid, get GPU address. So that would be this part, and then for the generate one we do as well. So we can do U64 well, grid address. Maybe we can. Yeah, it's like anyways voxel is kind of useless. Then we can fit another one here, which is the vertices, and now we fit another one here, which is the draw command of my buffer address basically, and then we fill that. So that is again volume chunk, grid, get GPU address, and volume chunk at where mesh vertices, get GPU address, and volume chunk, indirect draw, get GPU address. Then we get rid of that. All right, so we have that part. The terrain panel we completely killed right now, right? Yeah, we did. Perfect. So now we just need to adjust our shader. I mean, just is a good term. It's still a lot of stuff. Is that the right directory? No, it's not, I think. No. Okay, whatever. Yeah, that's perfect. Yeah, let's not do that for now. I will look at that later, but I think I already kind of... Oh, well, I should submit it as well. Then I fixed it. Fixed issue with MSVC variable being undefined because it was used before the call to... Alright, so we got that out of the way. So the init one is the one I would want to fix first. So how does that look again? So we need this extension, which we probably, I mean, for now we will put it here. It doesn't really matter. So how does that work? So we do layout buffer reference, voxel grid, I guess. Oh, okay, well that's just a forward declare. I guess we don't need that. I think this is enough. And I think we can get rid of that. And then this is this. Voxel grid. Voxels. Or like grid. Or like... Let's do it like that for now, I don't know. And then how do we access it? Oh, it's just... Hey, Sedeshaw, thank you for the raid. Thank you, thank you, thank you. Let me quickly go and welcome everyone. Let me quickly... Where is my Twitch? Thank you, thank you, thank you. How was your stream? It's going good. We are adding buffer device addresses today for Vulkan. So this thing here, if you're familiar with bindless texture rendering, this is the same thing just with storage buffer, uniform buffers, vertex buffers, anything like that basically. So you don't have to bind your descriptor set anymore. You can basically do some C++, C-like pointer arithmetic on the GPU with your buffers and arrays and stuff like that. It greatly simplifies the, or it opens up a lot of potential that you can do in terms of how you sync data to your GPU and in what format and what you can do there. It especially helps with like linked lists and stuff like that. Makes linked lists a lot easier to handle. That is a 1.1 feature, but it got moved to 1.2 to core in 1.2. But it actually is already in 1.1 as an extension. But yeah, since 1.2 it is basically a core feature. It's funny that you say new Vulkan, right? Because I think 1.2 is already quite old. I mean, I'm as well on Vulkan 1.2 still, but I don't think Vulkan... I wouldn't consider it probably new anymore. What does it say here? It's 2020, so it's like... I mean, yeah. It's already 5 years almost now. Actually, it is exactly more than 5 years already. Because in January 2020. And I think it's already on... Isn't Vulkan 1.4? Didn't it just release? I think... Yeah. I think there were a couple of things that I wanted to try from Vulkan 1.3 and Vulkan 1.4, but not sure anymore on the top of my head right now. But I think aren't mobiles nowadays already as well on 1.2? Well, maybe not like the weak ones, right? Probably not. Like the older phones, probably like definitely not. Alright, so where were we? So we added this grid here and we wanted to see how we access that. So we give it the reference. So in here we got like the U64, right? Ah, okay, it's like that. So this is grid address or grid pointer. And then in here we do all of that stuff, which is fine. And then we say this dot, or do I just access it then? Maybe I just access it with the index, right? Chances that my graphics card dies are high. I mean that we crash. And then maybe the stream is gone. Let's see. I will be back if that happens. Wouldn't be the first time that happens. You can quickly destroy your OBS when your graphics card crashes. Cool. Yeah, enjoy your food. Enjoy your dinner, I guess. Well, no, I think you've, yeah, maybe dinner, I don't know, or lunch. I'm not gonna sell my kidney. No, but I mean, I don't plan to do a mobile game with that engine anyways. This is not an engine for mobile games, I would say. So either we horribly crash now, or I don't know. Oh, we need to do the other part, the other shader as well, right? So this one here. Oh, that one will be a little bit more hard, I guess. So we get the voxel grid here. Oh, it's way more. So we get the voxel grid, which would be getting rid of this. And then let's get rid of that. And then we need to do another one, which has the vertex. Let's do it like that actually. Then we can get rid of that. And then we do another one where we do VK draw indirect. Here, draw command. Draw commands. Or like just commands maybe, I don't know. Draw command buffer. Then that gets removed. And then we have vertex buffer here. Mesh or like vertex buffer pointer. And then we have a draw command buffer. The naming is not really that important. So it's like that, right? So we had it like that and then like this, and that was how we aligned everything. Then we do all of that stuff here. So this then would be U constants dot grid pointer at that address. Probably. But actually it's called cell here. Which we might need to do, right? Do we need to reference that? Hold on. Where is it? Oh no, where is my second? Oh, here. So we do registers references. Oh wait, it's... Oh no, registers is the push constants, then we do references dot buffers. And dot buffers is this one, so we don't call this. We just access that directly. Perfect, so we don't do grid pointer here. Well, we do grid pointer. And then we do cell or cells, probably. Like that. Probably. And then here we do U constants, draw command buffer pointer. Dot vertex count. How does that work? Hold on. Commands vertex count. Was that only one? Did I now kinda... No, it's in here actually. Ah, it was only one. I mean, in that case, I think we can only do one anyways, still. basically this u while u constants dot draw commands, buffer pointer commands, this. It's not very nice. I think we can probably wrap around a little bit to make this read a little bit nicer. Because that actually is a little bit a mouthful to read. But what can you do? I think that was all of those. I have such a bad feeling this will horribly crash. This will horribly backfire, as I said already. And then we have this one, which basically here, all three of those u constants dot that dot vertices. Yeah, so that's fine. So are we taking bets that this will completely explode and we will see each other in 2 minutes or something like that, probably. So I think, yeah, I give it everything. Let's see. Perfect. That is at least better than what I expected. Required extension not requested in init volume. Did I not? I mean, it's here. Or is it called again different? Is it called different again? And it kind of trolled me. Huh. Why is it? Why is there a UVec2 then here? It wants reference to. That is write only, read only. Okay, that's another thing. So probably here. That is write only, yeah. That is read only. So that's one thing, but that doesn't make it that much different. Can't read from write only list and generate volume. Ah, okay. Well, 94. Huh. That's actually pretty nice, to be honest, that we have this kind of logic here now. But I think we still have that we need this, which is kind of weird. I'm not sure why that is not referenced in the... Ah, okay, because we access it. It is because we want to, because we... I see. It's probably because I do like the pointer access, right? Or like the array access. Well, we can enable that, don't worry. Unfortunate. Init volume 39 cannot index buffer reference. Oh wait, grid pointer. Oh yeah. That's garbage, of course. There's... I mean, almost. What is it now? Ah, okay. Handle. Mesh vertices. Where do we want to bind that? What are you? Generate volume mesh. Ah, wait a second. I mean, even then, I think let's restart. We should probably just not crash, yeah. Maybe. Or actually, we can kind of get rid of that. Probably we can just override is enabled here. Like that, that should already make it disappear. We have to delete that node anyways. Okay. I mean, we are here and we are not crashed yet. And we crashed. Am I back? Is my disk like your OBS start? No, it's not. Alright, so we definitely crashed. Let's copy that. Let's see, what does my output say here? For each byte in the range specified. So I guess something with the push constants. Doesn't match. Something with the push constants. So those are 32. I mean, that should be fine. That should be 32. Let's do one step at a time. Let's remove that. Let's see. Although that already... No, that doesn't need to be. Okay, so that runs, which is not bad. So maybe that is fine, right? So it's this one that is a problem. There we have two addresses, another one and a float. That should be perfectly valid. So we have the grid and the vertex address, then the draw command buffer, and the cell size. That should be fine. Famous last words that this should be fine. Oh man. I have to change this overload. I passed in my whole beautiful push constant struct and then I only gave it one float in size. Actually, let's do that now. I'm sick of that one. So we do that, but this one is actually private. Or like protected basically here. And then here we do a template. Type name T void bind push constants. The offset we will still take, right? The shader stage we take. Then we take a T, probably a const T reference, right? And then we just say bind push constants. It's a void pointer. Why is it a void pointer? Can't this be a... It can be a const void pointer. Okay. That's what I thought. So that makes that at least way simpler to use. Because now we can do here. Oh, maybe I shouldn't have. Well, but I can do that. That. We have a couple of errors now in every place where we do the push constant. Oh, it's anyways nice to do it like that. Oh, come on. Don't be annoying. That's way better anyways. In so many ways. It's just that we have a lot of them already. Actually, I have a lot more shaders than I thought. Actually. It's something I noticed as well recently, that I have like way more things already in the engine. It kind of grew quite a lot over the last year with all the different features that we added. I mean, it's nice, don't get me wrong, but it's well hard to maintain by now already. Oh, but that, I don't know, even know why I didn't do that in the first place. That is my renderer multi-threaded? Not yet, no. I mean, we run. It's a little bit. The rendering currently still runs on the main thread. It is prepared to do multi-threading, but I didn't fully implement it yet. And we have a separate present thread. So the actual present on the swap chain is already on a separate thread. So basically the idea would be that... where is my beautiful paint? So we have... let's actually... holy shit, my eyes. Let's do that. So we have basically the CPU here, rendering, and then present. That's the kind of idea. So here we have the CPU. Then here we have render. Which we make a little bit smaller. Can I... where is the text size? Ah, here. I'm blind. And then here we have the present to the swap chain. And this one would be as well split a little bit into tasks, basically, where we have like, because we have a render graph, right? So we can probably do stuff in parallel at the same time. Hello, Stanislav. Thank you for the follow. Thank you, thank you. So the theory would be that the renderer, I mean, the CPU is multi-threaded as well, right? So we will run multiple stuff at the same time here as well, on different worker threads. But the GPU, we can probably multi-thread as well, the command batching or command queuing. But currently both of those are running in the same thread, and we only have this part for now. And why did I move the present to a separate thread? It's because presenting actually takes quite a lot of time. And you can already move forward with the next frame. You don't need to wait for present to finish. So this VK present actually takes a lot of time, because you as well wait for the... like if you have vsync, the present kind of blocks a little bit, as far as I remember. At least this can take quite a lot of time, the present. So you would want to have that in a separate thread, especially once you add something like DLSS or FSR3, like with frame generation. Then you want to run stuff on a separate thread for the present, because the generated frames you run in a compute shader away from your usual render pipeline. And then you need something like frame pacing, which this present thread will take care of, so that we keep our 60 frames per second. That's the idea why I already split that away. Because, yeah, it's more or less a future thing if we ever add generated frames. I didn't crash. But I don't see anything. I don't see anything because I don't have a material. Let's hope. Not too bad. Not too bad. I can live with that. Not quite sure what happens, to be honest, but it's something. What? Let's see. let's look. Let's see actually if RenderDoc cannot do that. Because that's another thing. Hello. Resource. Hello, Shadow 2. Resource state tracking would be a bit more tricky though. Yeah. Yeah, probably, yeah. Although, is it? Because I think, I mean, the split here, you basically need to guarantee that you split in a way that if you access resource A here for a write, this one is not allowed to do a read, right? And only those are reads on this A resource. And then you can split it, I think. As long as you, like, you need to, of course, and my render graph already orders the tasks anyways in like order of dependency, basically what is read and what is so basically, let me actually open it. I mean, we definitely need to probably extend it quite a bit, but you can see that we have like the links here, and then we know what depends on what. So we can probably split that into like stages that we can multi-thread and stages that we cannot multi-thread. So basically all of those can kind of run in parallel, right? Because they don't really depend on each other. And we only need to wait for them here. More or less. And the render graph has that information because it orders them already, it sorts them already so that everything is executed in order correctly. But currently everything is like, yeah, in a synchronous like chain. But it shouldn't be too hard to do the resource tracking. I delay the barriers to execution submit time to solve that issue. Ah, okay. That is very similar to what Snowdrop actually did. In Snowdrop, they had a system where they basically pushed all the resource transitions to like a stack queue kind of thing, and then once you called draw or dispatch, it processed those. No, it's not Onyx Engine, sorry. The title is a little bit, or I mean, it's the Onyx Engine, which is my own. Irrlicht is the project of the name of the project that I'm working on in the engine. So you can see it here if you want to have a look at the engine. But be aware, it's very, very much in progress and very new. But that's not what I wanted to look at. Let me close that again. Perfect. We still have that shutdown crash, which is amazing. Probably should fix that for the next version. Let's create the material again here. Alright, so we have our beautiful broken meshes here. Oh, I didn't fix my labels yet. Okay, while we have it working. Mesh viewer. Not bad. That's a flat plane. That's not so much a flat plane. That's a bit weird. That's a flat plane again. I wonder what's going on here. So all of them look kinda okay. Except for some that are like weird as hell. And shouldn't they all be the same size? That's another thing, right? So all the ones that are busted are definitely wrong, because I think they should all be the same amount of triangles, because it's just a flat thing. So the question is, where does it go wrong here? How do we best debug that? Because I don't think I see my voxel grid here anymore. Might be actually able to. Never mind, I might be able to see that. Wrong. Well, I doubt that, because some are working, some are not, right? And they are all rendered exactly the same. So that's the weird part, right? They all use the same shader and the same shader to create them. So it has to be... Maybe it probably has to be some sort of... I don't know, actually. Because the thing is, we definitely... Pipeline state. I mean, they are all the same size, right? Let me think, what could that be? Is it as well maybe that certain positions are broken? Could that be it? Let's do one thing. Let's actually... Although no, that doesn't matter. No, forget what I said. I wanted to say that maybe the position of the chunk is a thing that breaks it, but we are all on the same position currently, so that can't be it. And it can't be the count. Where is it? Create volume mesh, yeah. I think we can get rid of that. Just so that we're not using that. Ah, that's the wrong one. But still, remove it. Don't want to have that anymore. And let's get rid of that. That's like definitely stuff that shouldn't be here anymore. Could it be that? Maybe. Let's see. I will double check something. volume terrain system. Although, I mean, it shouldn't matter, but maybe it does. Cluster count. Maybe, how much is that? Okay, that's definitely not good enough. That might be good enough. I don't have any 3D objects currently. As weird as that sounds, I don't have any 3D objects. All the meshes that you currently see are generated on the GPU. Because I'm doing volumetric terrain and I did not add any mesh loading currently. I mean, I have one, but that is kind of broken. And let me double check what I used here. I think I just read OB, like a FBX file, I think by hand. But that was just some debug stuff where I had wanted a debug sphere, so that's not like in any way, shape or form the thing that I would want to use. Probably it will be something like async in the end, but I didn't decide yet. Max vertex count. What is it that you didn't? Oh, we have the terrain panel. You know what? I don't care about you, terrain panel. We do this, Mr. Terrain Panel. That's for the editing the terrain panel, so we don't really need that right now. Validation error. That is a little bit sus. That might actually be a reason why it's broken. Invalid vertex count for component. Is that here? Yeah, it is. Why? Let me double check some things in the diff. So all of that, I don't care. Yeah, that's fine. That's all fine as well. That is as well fine. That as well, and that as well. Should be correct. if you do, I suggest you stick with async 5.0 because I tried 6.0 and I have huge problems with it for animation. Oh, okay, good to know. Good to know. We'll probably note that down somewhere. Where do I want to? I wanted to check something. Oh yeah, in the... Not necessarily here. And not here. Where was that? Volume terrain component? No. Volume terrain system, maybe. Actually, no. Generate mesh pass, that was it. So we had an 8x8x8. And that was that for the voxel grid. Which is fine, because we still have that. Not quite sure why we have... Oh, well, whatever. I guess that's fine. And then we have... For the generate, right? Exactly. We had one by the... Like, one shifted by 19. For the buffer size. And then mesh vertices just had a size of the vk draw command. That should be fine. And what was the cell size? Oh, we didn't have that anymore. Oh, but the cell size was 0.5, okay. So I think that's still the same, right? Yeah. Huh. We don't really get anything particularly broken. Except for that, yeah, this command buffer here kinda spews out quite a lot of garbage. Let's actually do one thing, so... It's always one that's like, okay, how many are broken? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? 10 are broken? That's a little bit sus. It's a very odd number. I wonder why that would be an issue. Oh, we still have that actually. Hold on, we still have that push constant stuff. Wait. What? Overlapping offset 0.32. What? Isn't that bind shader effect here? Shouldn't that be fine? And then we can't do that? So if I do just that, right? Is the arrow then gone? And it's gone, yeah. Ah, well, never mind. We need to load first. Oh no, it actually is not gone. But which one actually? If I get rid of that, let's see, because maybe it's the stuff that I added now that I did change to the template. No, actually it's not. So it is something with this buffer here. With this create push constant here. But why? Isn't that fine? Wait, did I not? No, I saved that. Then we have float, distance, and then we have the grid pointer and the cell size. That should be fine. Wait, buffer reference align. No, I mean, shouldn't that be fine? Should probably be fine. But we could probably verify if the push constant is the correct size. Where do I do that? Shader compiler. Push constant range. Put a breakpoint here. Do a space here. Run again, and then we end up here. Size 28. So do I need to do a padding here? Just to be lined? That's kind of weird. I've never had to do that in my mind actually, but okay. Fine, we can do that. Don't think that will be the problem though, but maybe it is. Do we need to do it here as well? That's 4, well that's 8 and 8, so that's float 4. And then yeah, we need here float padding probably. Just so that we have that as well. Don't think that will fix my problem, but we never know, right? As I said, validation errors are not there for fun. They have a purpose. I just doubt that that changes anything, but yeah, we still get this invalid vertex. Maybe we need to, hold on, maybe we actually need to terrain panel. Probably actually need that. So in between here we need a command buffer barrier for that buffer. Yeah. Oh, well, okay. Really? God damn it. But I cannot make that non-const. We have a little bit of a problem. Can I make that barrier? Like, I can't make it const. Although maybe I can. Maybe I can make. No, I can't. I mean, I could const cast for now. Yeah, it is. It is. It is. It is always aligned to that. I think it's just that we are missing a barrier. And I now need to find a way how to properly do that. Buffer handle. Can I do that? Do I really allow that? Wait a second. Can I do that? Can I get from a const ref? Because I'm pretty sure that is const, right? Or whatever. And then we do a shader read here. God damn it, I thought that might be it, but maybe not. Yeah, it's not. Or does that even work is the other question, right? Oh, well, maybe we need the other one as well, so... Let's put that here, and then we do a command buffer here. From... I don't know, I think we have it somewhere here. volume terrain panel. Or we do compute shader right actually, yeah. Oh yeah, that's the, yeah. So we first transition our buffer to compute, and then we transition it back to read, and then we do that stuff. Constant buffering in the beer. Yeah, that's actually true, yeah. It's card. It's not card. A constant. Oh, we fixed it. It was a synchronization issue, I think. Oh, let's see. Beautiful. Because we're not generating it all the time, we are generating those only once, right? So the problem was that we launched 2 compute shaders in succession. One is writing to buffer A and the other one is reading from buffer A. So we already dispatched and were processing memory that was not synchronized. So we need to mark the buffer that we write to it, then we dispatch, and then we transition it back to read for the next dispatch. And it didn't flicker because we only do that once, right? We don't generate the mesh new every frame, because we don't need to generate it if it doesn't change. Yeah, more or less, yeah. I mean, it's probably not really at the same... I mean, yeah, maybe, I don't know exactly. But even if it's not at the same time, maybe the memory was not flushed because, you know, like off caches and stuff like that. So it could read like memory that was still stale because it didn't get updated because the barrier was not telling it that the other shader needs it. So it doesn't mean necessarily that it ran at the same time. It could run one after another, but it's the same on the CPU, right? If you don't have atomics or something like that, or locks, then it doesn't need to go to the L2 or L3 cache, so you can read garbage on other threads, potentially. Which sometimes is not a problem, right? For a pull flag, it doesn't matter if it comes a little bit later, because eventually it will get to the right cache. You're in luck, it's very hard to debug in multi-thread, and even more so with GPU. I mean, you have RenderDoc, right? RenderDoc helps with GPU debugging, and in general, multi-threaded, it's... yeah, it can be difficult, but it's okay. I can only recommend, at least in Visual Studio, I don't think... I mean, Rider I think has the same, but in Visual Studio I can definitely recommend parallel stacks. That is like amazing thing, right? Where you see all the stack traces of all your threads at the same time. So you basically see where each of your threads is currently, and that helps quite a lot. And then it gets a lot simpler with that, and yeah. Yeah, it's definitely a nice thing. Can only recommend it. Visual Studio has some awesome stuff, so that's why I still use it. Because I don't think you have something similar in Visual Studio Code, but not sure actually. There might be. My wrist is a little bit hurting, but I want to get one more thing done today. Which is now we have the meshes. Which is one thing, and now we need... Can we do that actually currently? I don't think we can. We don't have that support yet. But let's see, how can we add that quickly? Static mesh. Not static. Maybe static mesh. I think we don't need that. That was an oversight. What would be the easiest one? You know what? I will do it different for now. It's not the best, and we definitely have to do that. Although that it's kind of shit, not gonna lie. I was thinking of moving the positions here off to the side, because currently all the chunks, so we have 3x3x3 chunks, right? I mean, I can definitely do that again here. No to all, but they are all rendered at the same vert position because I don't give them a transform currently. So all of them, we will have like 3x1x3 because we removed the y coordinate. Here, yeah. So all of them are rendered at the exact same position. I mean, here you don't see it, but I mean, here you see it, right? In position, out position. They are all more or less the same. It's just that it's a little bit different because the compute shader runs like not very like deterministic, right? So then we have like an offset sometimes here in the start and end position, but the min and max of the vertices is always the same. So we need to shift them, and currently my static mesh shader doesn't support a transform for the object, which is something we need anyway, so might as well add that. I think we should still have space here, right? I mean, it will be tight. It will be tight. But I think it works. But I cannot add it here actually. I have to... Wait. Oh yeah, that was anyways wrong. I mean, it was not necessarily wrong, but it was a little bit wrong. Yeah, exactly. Here for the transforms, we have to basically offset that per transform. So we have this one here, and here we have the transforms. Now we do transform in, okay, maybe not here. It's an indirect one, right? So this one is the one we currently really care about. So let's do it here. So for each of those in the indirect draw call transforms. So we have this at 64. So we should be able to do another bind here with offset 64. transform matrix. Right. That should work. Do we have that? Okay, no. That's something I can do. And then wherever we bind that, here, we do volume transforms and place back at volume chunk coordinate times 32, I think. Oh, and place back matrix for how is it again? Oh, column. Okay, that's unfortunate. We probably should. Actually, we can do it. Hold on. Matrix 4 Onyx F32 transform at column 3 as that. Vector 4 F32. Isn't it that? Yeah. Can I not assign? Huh? Say what? Here? Hello? Oh, wait, okay. Do I really need to do that? All right. Let's do it then. Stupid X times 32. Let's make it ugly for now. Y times 32. Z times 32. And this one is always 1, I think. Or is it 0? Oh, I think it's always 1. In the column last, right? Because we have the identity there. And then we can do that. That should still work. And then we just need to go to the shader, which is in the game project, which we currently have to edit by hand because I do think I broke it quite a bit. So this one here. Oh. Well, does it matter? Yeah, it does actually matter, right? Yeah. But how does that actually work here then? I think I can do that, right? And then this is just a mat 4. I think we have it in the ImGUI one as well. Yeah, exactly. We have different push constants here, right? Oh, we don't have a push constant here. Well, that sucks. Did I not have a push constant somewhere? Of a U4, of a Met4. Oh, here. Exactly. Met4 model. And then it's, I think, just you. I think it's just model, right? I can access it like that. Maybe. And then in here, no, not in here, in static mesh, 0 vertex. Not sure if I need to offset the fragment now, but I don't think they interfere with each other. That one I'm not a lot, like that one I'm not too familiar with, if I need to offset them now or not. That doesn't look like it. Oh, there it is, but okay, we get a lot of validation errors, so probably okay, yeah, so we do need to probably offset this here by 64, which is the size of the matrix. And then we should hopefully have our texture again. Unfortunate. Do I need to specify the offset for the push constant? I've never done 2 push constants yet, to be honest. Push constants, Vulkan. Or maybe I'm just not doing it correctly. I mean, that is another potential thing, that offset. Do I need to do an offset there? Oh, there is. So I guess I need to do that then. Basically here. 64. Is that then the whole thing offset, or do I need to do that for each of them? Okay, I need to do it for everything? That kind of sucks if that's the case. Do I really have to do that? Is that really how it's done? That sounds painful. Well then, in that case, let's actually not do that. Let's do this here and move that to 64. And we keep this as is. And then we do this one here. Again at 0. And this one at 64. Because that's way simpler, because it's only one. But I have to read that up if that's really how you do it. Okay, we still get warnings for the push constants, I think. Yeah. Not quite sure why. But whatever. It kind of works. Okay, so now we have a bigger patch, right? Instead of before. We cannot edit it yet because I disabled the edit. But in theory, we should be able to add even more. So if we go to volume terrain system and we now up that to, let's say 6, we will have an even bigger patch. It takes actually quite long to generate, which is something I want to investigate. Yeah, so we have bigger one. Oh, and it actually starts, because of the log probably. Because my log is currently spammed as much as it could be spammed, I guess. I guess we could disable that log. I'm not sure why it even logs it. Why would you say that the push constant doesn't... Must contain all stages. Oh, okay. Okay. So you're telling me I have to do here fragment? And here as well, or what? Do I even support that? Wait, do I even support that thing? 2 Vulkan stage. I don't. I guess we just do an all in that case. Whatever. So does that satisfy you? And is my frame rate normal again? No, it still spams. What is going on now? What? Unhold. Okay. Okay, then it doesn't support that. So we need to make this support here. Okay. Is that even a bit flag? Can I do that even? Oh, it's not even a bit flag. God damn it. I mean, in that case, it probably actually works. So let's actually handle that. So if... So basically case... I mean, it's basically that case. Nah. Alright. I do hope I'm not... I'm serializing that right. You know what? We give it all, and in all, we currently return that. Huh? Isn't that how it should be? And then we go back to our volume, our terrain here. And we give it all again. But we will fix that tomorrow. If that now fixes the issue. Which I hope it does. So we need to... Oh, that's actually a bit of a pain because the shader is not prepared for that. What? What? How come that suddenly fails? In what pipeline even? What the hell? Core stack? Locals. Create light cluster suddenly fails. Okay. How did I manage that? Is that here for some reason? Where do we core that? Oh, we actually do that core that here. Is it maybe cored here? With a stage that's invalid? Compute. Oh, we have all here. Core stack. Light cluster. Why would you be an all? What? Where do you get that from? Ah. Ah, okay. Okay. I see. So we keep that. And we add another one. Oh, whatever, heck. Alright. Then now we can do that in our beautiful static mesh. Let's do that. Alright, but with that I will probably call it a day. We will raid someone else and we will be back tomorrow. Same time as usual. So 7:30 probably. Or like not probably, for sure. 7:30. And then we will make, well, we clean this up and we will make it so that we can edit it, because we kind of killed the edit now. And then I think we might move on to something else, but maybe not, because there is a lot of stuff that we still need to do for the edit. We don't have any brushes, we don't have an undo, redo, which will all be very, very painful to do on the GPU, to be honest. Okay, cool. Got that one again. So that will take a little bit of time. We need to do a rebuild. Sometimes that happens and C++ just shits itself and then it links something weird in the project. I still don't know why. But I have that at work as well in the AAA project that I work at work. Sometimes I synchronize, I build and something crashes randomly and then I do a rebuild and everything is fine. It's a C++ linker fuckery and maybe it's probably something with Windows where it thinks the file is up to date but it's not, and yeah, whatever. It's fascinating. Let's see already, who could we raid? Someone on we follow? What is that one again? Can I? Not sure. Maybe we raid someone else, someone new today. No, let's see. First, let's see if that works. Okay, so we back in. See, everything works fine. You just have to rebuild and it suddenly works. C++ is really fun sometimes. Well, maybe I shouldn't blame C++. Maybe it's like Windows. I don't know. Okay, no, we still have... Okay, I give up at this point. I have no idea what this push constant is about. We will investigate that tomorrow. But because of that spam, we basically kill our frame time. Alright, but with that being said, let's see, who could we raid? Is there... The usual suspect is... Let's see if there is someone doing Vulkan. Probably not. Because it never happens that someone is doing Vulkan. I wanted to raid someone else. Is there C++? Only Russian. Well. If you have any suggestions who we can raid, then let me know. But otherwise, let's see. I definitely would want someone in English, please. That sounds actually not so bad. Building a unique rhythm action roguelike. Let's check it out. Alright. Because I wanted to... Yeah, exactly. Is it? Yeah. Alright. Thank you very much for joining. See you tomorrow at 7:30. And it's not right now. But yeah. Thank you. See you tomorrow. Have a nice rest of your evening. Bye bye.
The Irish John. Let me find your Discord. I should join there. I think it's pretty cool. Oh, and we're getting grades. Okay, let me